Hi, we're going to do Pythagorean Theorem, which you may or may not know. Pythagoras was a guy a long time ago who popularized this theory, and you probably heard it before: a squared plus b squared equals c squared. This only applies to right triangles. If it's not a right triangle, if you don't know it's a right triangle or you don't see the right angle, it doesn't work. A and b doesn't matter which side it is, but c has to be the side opposite from the right angle, which hopefully you know is the hypotenuse. So let's jump right into a problem. 3 and 4, we know these two sides. Typically, you're given two sides and you have to find the other one. So we know that. Let me write this down real quick. 3 squared plus 4 squared equals, I'm just going to say x squared. You can do c squared, you can do any letter you want to. But we know that 3 squared plus 4 squared has to equal whatever that side is. So we get 9 plus 16 equals x squared, and then we know, oh, that's 25 equals x squared, and this is what's called a Pythagorean triple because it works out really evenly to an integer. Because if we take the square root of both sides, square root to undo the square, we end up with square root of 25 is 5, and so square root of x squared is x, and square root of 25 is 5, so we know that side is 5. 3, 4, 5, very common, what's called a Pythagorean triple, comes up on a lot of test problems. If you see 3 and 4, just know it's 5. You can work it out, but it's going to show up a lot. Okay, a little bit harder one. This is a right triangle. It doesn't look like one, but I've got the right angle in there, so it is. So we've got 5 is this side, square root of 50. Now this is a weird number. It's a weird way to write it, actually. You would probably not normally see it that way. You'd probably ever see it as a decimal, which we know that the square root of 49 is 7, so that's got to be a little bit more than 7, and if you put in the calculator, it's about 7.1. There is another way to write this, which I'm just going to show you because if it's a multiple choice test or something, it may just be written a different way. But there is another way to write this because 50 breaks down, and this part right here, if you don't get it right now, it's not a big deal. We'll go over it later. But 50 breaks down to 25 times 2. If there are any hidden squares in there where I can multiply things out, that's important. So the square root of 50 is the same as square root of 25 times 2, which means, oh, that's the same as square root of 25 times the square root of 2. So occasionally, instead of saying square root of 50, whether that's an answer or a starting point, you may see that written as square root of 25 is 5 root 2. 5 root 2 is how you would normally say that. Now, once again, if you don't understand that, if you don't get it, don't worry about it. Square root of 50 is a number. It's just not written the way that it is in most textbooks. You should recognize, though, you put it in your calculator, you get an answer, or more importantly, you can estimate, oh, it's a little bit more than the square root of 49. Doesn't change how we do this problem. We're going to say square root of 50 squared. This is actually an easy problem to do. Square root of 50 squared, which is 50, because square root of something and then square it, it's 50. So that's super easy. Plus 5 squared is 25. And we know it has to equal that third side squared, whatever I want to call it. A, B, no, I can't call it A or B. X, C, whatever it is. The hypotenuse has got to be that. So I get 75 equals C squared. Now this is where you have to think. That thing is not 75. That would be much too large because we know this is 7.1 and 5. That can't be 75. You got to take the square root of both sides. So this is where sometimes you have to think, does my answer make sense? Because you can stop too early. Okay, square root of C squared is just C. Square root of 75, if I put it in my calculator, that is going to be approximately 8.66 or 8.7 if I round it. And once again, I should recognize this is between 64 and 81 squared. Those are my two perfect squares that it's near. 8 squared is 64, 81 is 9 squared is 81. So it's got to be between 8 and 9, even if I don't have a calculator. So a perfectly fine answer, unless I ask for you to otherwise, or unless it's a multiple choice test, 8.7 is a perfectly fine answer. That's 5, that's about 7.1, that's about 8.7. Now, just so you can see it again. I'm going to break this apart, okay? This I can factor. I'm like, oh, that's 3 times 25. And 25 is a perfect square. A little off the screen here, sorry. So another way to write this, square root of 25, and it's not always going to be 25, times 3. And so the square root of 25, getting off the screen here, and the square root of 3, see how that breaks down? I'm like, oh, that is 5 root 3. What you will find if you put 5 times the square root of 3 in the calculator, you will also get 8.7, same as square root of 75. This is just the way that mathematicians like to write this a lot of times. They like to what's called simplify the root. So that's just one additional way to do it. Okay, I'm about over my time here. Let me do one more real quick. Okay, right now, can't use it. Got to have the right angle in there to know that this works. Okay, notice I've got a 9 here. That's not an A. I got 7 and 9, and I got something here. This could be A, this could be, it doesn't matter. I'm going to make this a B just because it looks differently. So that's my A, that's my B, that's my C. So I know that 7 squared plus B squared is equal to 9 squared. Now, first of all, I should just think about this problem. It certainly can't be more than 9. And if this problem is to scale, it's less than 7. Now, it may not be, but can't be more than 9. It doesn't make sense for that side to be more than 9. So if I get a number bigger than 9, I should stop. I did something. Okay, I got 49 plus B squared equals 81. Now, this is a little bit different. I'm trying to solve for B. So I'm going to subtract 49 from both sides. Okay. That's going to give me B squared is equal, and I think I did this wrong a minute ago, 32. And then if I take the square root of 32, take square root of both sides, I get, that does break down. That breaks down to, is that 16 times 2? I'm hoping I do this right. So first of all, square root of 32, I can just put my calculator. It's 5.6, I think, roughly. Okay. So that's a fine answer. 6 point, no, not 6 point, 5 point something. 5 point, I looked it up wrong a minute ago. I think it's 5.6. It may be 5.7. That's a perfectly fine answer unless I ask for it in broken down form. Now 32. 32 is actually 16 times 2. Didn't know this problem was going to work out this way. I hope I'm doing it right. So I've got a perfect square and something else that I can't take a perfect square. So the other way to write this answer is square root of 16 is 4, and then that root 2 is left over. That is another way to write exactly the same answer. Sorry, I'm all over the place. Okay, a little bit longer than I had planned. That's all. Once again, don't get hung up on this part. As long as you can get to here and say, well, square root of 32 is fine, or about 5.6, this is just another way to write the answer. Don't let that slow you down. It's kind of like reducing fractions.